Hello, this is Mike Lively of Northern Kentucky University, and this is the final of 3 videos on a Molfile molecular viewer created in CS4. And let's take a look and see how we create a molecule, atoms, and bonds. Now previously we looked at the atom subclass, and once you have that, you're ready to create molecules and bonds. And in order to do that, you have to do 2 things. You have to place the atoms, and you have to create the bonds. Now, it's all just a counting game at this point. You just want to place the atoms, so pretty much, just like the last post where we place balls, you just remove the draw path's random settings to actual specific settings. And those specific settings are attained, the X position, Y position, Z position of the atom from the Molfile data. And if you look at the start vertice and you count 1, and that first position is the X, that second position is the Y, and that third position is the Z, as was shown in the first video. Now there's 16 columns, so you have to multiply by 16 to hop down to the next row. And then we have the scaling factor. Now there's also an offset, and what that offset is an average of X, an average of Y, and an average of Z. And the reason we do that is so when our molecule spins, we'll actually spin it from the center. And let's take a look at that real quick. So here's our molecule once again, and you can see it's spinning from its center. And the reason it's spinning from its center is because we took the time to calculate that offset value. Let's go back. So that's all there is to it. You've created your atoms. You've thrown them into place, and you pulled that data right from the Molfile. So the next thing you need to do is create the bonds. And there is something different that we did here, and let me just explain it to you real quick. We actually had a conceptual change here. So in the past post on draw paths, we created a number of markers and had all the lines follow the mark. And in that process, we had a double process. So instead of doing that, we just removed all the double processing and just created 2 sets of balls or atoms. And we threw 1 atom in the atoms array and 1 atom is in the marks array. And just like previously, the sorting occurred in the atoms array and the drawing occurred in the marks array. And that actually was a very efficient way to do it. Now we had to pull our bond data, and the way we did that is we took our start vert, we multiplied by the number of atoms times 16 to skip all the atom rows and started in the first one. That gives us our first atom, then plus 2 is our second atom, and plus 3 is our bond number. And that's how we pulled all the data to connect our atoms and lines. Very, very simple process. The only thing that really gave me some time to think was how to create double, triple, and aromatic bonds. And once again, it's all just a big counting game. What happens is that you create a single bond, but when you create a double bond, you have twice the data. So basically, you have to move the pointer in the array forward. And then if you create a triple bond, you have 3 times the amount of data. So if you move the pointer 3 times forward in the array, and that counting for commands was 2 star B, DB, plus 4 star TB plus 2 star AB. And basically what that is 2 times the double bond, number of double bonds, 4 times the number of triple bonds, and 2 times the number of aromatic bonds. And for the M data, that was 4 times the number of double bonds, and 8 times the number of triple bonds, and 4 times the number of aromatic bonds. And basically I calculated all this in my mind. It seemed to be right. I threw it in the code and I tested it, and it worked or didn't work, and I readjusted it and said, oh yeah, I see how the way this is supposed to go. The final thing you need to do with the DB, which is the number of double bonds, the TB, which is the number of triple bonds, and AB, which is the number of aromatic bonds, is that you increment those every time you create a bond, and so that goes into your counting array. And so you always know where your cursor is in your array. And what you want to do after you've drawn your molecule, then you set DB, TB, and AB back to 0. And on each iteration tick, they accumulate. And then at the end of that tick, you set them again to 0. And then you redraw the molecule, and you go through the same cycle over and over again. The final thing was actually drawing the bonds. And really, I didn't do a very sophisticated job of this. I just basically, for double bond example here, I just subtracted a bond X and Y and added a bond X and Y. And so it basically just drew 2 lines and separated them by a small increment. Very simple way to approach that. Of course, they weren't lined up at the actual atoms, but the atoms covered the misalignment, so they look great when you take a look at them. So that's how you did it. Just real quick here, I want to take a look at the final code, but before I do, I want to say one thing about where we're going. In working with this, I noticed there's a number of Molfiles on the web that were missing a 0 or had too many zeros in the wrong place, but that Molfile is very structured. In this case, if you don't have it in the right place, the parsing won't work. So you can easily go in there and you can correct them but your user doesn't know how to do that. So what I'm thinking about is possibly using an XML format instead, because with that you can also have chemical reactions. And I love XML. You don't have to worry about counting. You just grab the node, okay? And so that's pretty much all my suggestions are, and we're going to be looking at this in the future and possibly using this format to create chemical reactions based upon molecular information. Wouldn't that be cool? Finally, let me just show you the wrapper class, or the main code. And once again, how this goes is you have your import statements, you have your private statements, you have some bond parameters. You're starting to get all your parameters. You get your atom number. You get your bond number from the Molfile data by just counting to where it's at. Then you have your start bond array. It just drops you down to the bond array where you get your data from there. And once again, it's just a big counting game. Here's your offsets for your X, Y, and Z positions. Here's your atom positions set from the Molfile data. And that's all thrown into a holder, so basically you can keep track of where the entire thing is on the screen. Maybe you want to move it somewhere, like a side corner, and put some text beside it. And here's your add listener. It starts your animation frame, just like paper vision, but it's being done in CS4. So paper vision is extremely helpful because the structure is just beautiful. And applying that to CS4 once you've done paper vision is just so easy. After that, I start making bonds, and once again, making bonds, as you see here, is just a big counting game. There's a switch case here, and you look at the array bond number, and so you're saying what type of bond is that for each time you tick through a bond type. And when you get that bond, you just basically switch to basically a single bond. Then there's twice the amount of information for a double bond, and then triple bond, and then aromatic bond. And so it looks like a lot of code, but it's pretty much the same type of code repeated again and again, all based upon this counting algorithm. And now once all that's done, you just throw it into a draw command, and you're finished. Isn't that cool? At the end, basically these come from the last post on draw path, the X, Y, and Z rotations. And a lot of this code you've already seen before. So I hope you've really enjoyed this post. Let's go back and take a look at that molecule one more time. Hey, you know, it was just so easy, you know. Did this in a day, and worked from 4 o'clock in the morning to 11 that night. However, there were a lot of breaks. Playing with kids, going to Shakespeare Club, you know. We went to the gym, and then we had an ice cream float afterwards, root beer float. Shouldn't have done that, probably. And then we watched several versions of Hawaii Five-0 and Enterprise. So, you know, you can see I was working hard. But, you know, that's the life. Like, when you can do stuff like this, and it's so easy to do with CS4, it's just very rewarding. This is a very smooth development activity. Very few glitches. Things just seem to run great. I wish they all were like that. Thank you. This is Mike Lively from Northern Kentucky University.